Today we're talking about isosceles and equilateral triangles. So first off, we're just going to refresh our memory on what an isosceles triangle is. So if this is an isosceles triangle, then you know that two sides are congruent. These two sides are called the legs. If those are the legs, then this side down here is the base, and this point right here is going to be your vertex. If that's your vertex, then this is your vertex angle. It's important to know these parts in order to know what it's talking about when a problem gives you specific things. If that's the vertex angle, then these right here, those are going to be called base angles. Okay, so both this one and this one are base angles. So those are your parts of an equilateral triangle. Okay, so from here, we're going to go through and do some examples. Okay, so the first one is we want to use the diagram X. If ABC is isosceles with vertex A, when it says vertex A, you automatically know that the sides adjoined with vertex A are your legs, and those are your congruent sides. It says the measure of angle A is 130 degrees. Well, if that's your vertex, the base angles have to be congruent, because if you look at your theorems list, your isosceles triangle theorem tells you that if sides are congruent, sides of a triangle congruent implies base angles congruent. That would be your reason for a proof. So we know that since AB is congruent to AC because of the definition of isosceles, then we know that angle B is congruent to angle C, which tells us if all three of those have to add up to 180, if we just called these X and X, then 2X plus 130 equals 180. 2X equals 50, so X equals 25 degrees. Okay? So, from here, once again, they tell us definition of isosceles. So these represent your base angles, because when side lengths are congruent of a triangle, the opposite angles are congruent. You could set those equal to each other and solve. I encourage you to go ahead and pause the video right now. Try this one on your own. Okay, so your answer comes out to X equals 5. Now from here, we're going to look at example 3. This one says, find the length of AC in the isosceles triangle ABC with vertex B. So what they did in that statement is told you that triangle ABC is isosceles. They told you the vertex is angle B, which then tells us that segment AB and segment BC are your congruent legs. Okay, so in order to find AC, all we know is that AB is congruent to BC because of your definition of isosceles. So if those are congruent, then their lengths are equal. So we're just going to set them equal to each other and completely ignore this x minus 3 right now. So we'll say 3x minus 18 equals x plus 10. From here, we can subtract x on both sides. 2x, add 18. 2x equals 28. So x equals 14. Well, now if x equals 14, it asks for AC, which would be 14 minus 3, which is simply 11. So the length of AB is 11. From here, we're going to look at a proof, okay? So on this proof, they told us that angle 4 is congruent to angle 5. So I'm going to go ahead and write that down. Angle 4 is congruent to angle 5 by given, and then I'm going to mark the picture. From there, we also know that angle 1 is congruent to angle 2. And again, that was given. So we don't know that angle 1 and 2 are congruent to 4 and 5. So we are going to mark those differently. Okay? So from here, you know that you can see that angle 3 and 4 form a linear pair. So you're going to say angle 3 and 4 is a linear pair based on definition of a linear pair. And then since 3 and 4 are a linear pair, they're also supplementary by that linear pair theorem. Now, so we saw that 3 and 4 are a linear pair and they're supplementary to each other. Well, we can also see that angle 5 is a linear pair with angle 6, and therefore 5 and 6 are supplementary. Now, our goal is to prove segment AB congruent to segment AE. Well, based on what we're given, what we're going to be looking at is we're going to be trying to prove that ABC is congruent to triangle AED. Okay, so those are the two triangles that you're ultimately going to be looking at. Well, we can see from here that if 3 and 4 are supplementary, and 5 and 6 are supplementary, and 4 is congruent to 5, then we know from one of our really old theorems from the beginning of the year that angle 3 is congruent to angle 6 by your congruent supplements theorem. Okay, that congruent supplements theorem told us that if two angles are supplementary to the same angle or congruent angles, then those two angles have to be congruent. Supplements. So now we know that angle 3 is congruent to angle 6, okay? And from here, we can say that from here we're trying to figure out how can we prove these two congruent. We don't have enough information yet, and so what we're looking for is to be able to prove sides congruent, okay? So the only way that we can prove sides congruent is if you notice, if we look at this inside triangle right in here, and I'll color it blue, this inside triangle, well, it kind of looks more black on top of this, that's got two congruent base angles, okay? So if those base angles are congruent, then that means that by that isosceles triangle theorem, then, let me see, if these two base angles are congruent and that's its own triangle, then the sides opposite it have to be congruent. And if you remember, that's from our new theorem that says, we can say AC is congruent to AD because congruent base angles, which would be angle 4 congruent to angle 5, implies that, actually I'm going to change that. Base angles congruent implies sides opposite congruent, okay? So if the base angles are congruent, then the sides opposite it are congruent. Well, now we can see by angle, side, angle, side, angle, that triangle ABC is congruent to triangle AED by angle, side, angle, congruence postulate. Okay, so if the triangles are congruent, now we can go ahead and say our proof statement, AB is congruent to AE because of corresponding parts of congruent triangles are congruent, or CP-CTC. Okay? So from here, now if you want to find the value of x on this one, We're now going to be talking about equilateral triangles. When an equilateral triangle, all side lengths are congruent and all angles are 60 degrees. Equilateral and equiangular always go hand in hand. If it's equilateral, then it's equiangular. Okay? So equilateral and equiangular. So if all the angles of a triangle have to add up to 180, and there's 3 of them, and they're all congruent, because since it's equilateral, then it's equiangular, 180 divided by 3 is 60, so each one of these is a 60-degree angle. Okay, so if we know that, then 3x minus 18 equals 60. You end up with 3x equals 78, and x equals 78 divided by 3, which is 26. Okay? The next one, find xy, and they told you that angle x is congruent to angle y is congruent to angle z. Well, if all the angles are congruent, then that means they're all 60 degrees, which also tells you it's equilateral, so all the sides would be congruent. So to find xy, you would set 7x minus 24 equal to 3x plus 16, and you could find all the side lengths. Well, you would solve for x, and when you solve, you should end up with x equals 10. If you plug it back in, you end up with xy equals 46. This is a great one to use just to study. Okay? So, we'll be going over more sample problems in class tomorrow, and let me know if you have any questions.